For these notes, you're going to need these notes that Mr. Broad just gave you, and you also need these notes, which is the formulas for angles and circles. So make sure you have both out. All right, let's take a look at this first. Last time we talked about central angles, and a central angle is an angle formed by two radii, and its vertex is on the center. So if we draw a picture of that, we have a circle. Here's the center, that's where our vertex will be, and then we have two radii. And we know the measure of the angle is going to equal the measure of the arc. Here's our angle, and here's our arc. We've done problems like this before. So, for example, in these pictures, the vertex is right here on the center. It's formed by two radii, so this angle equals the arc. So 65 equals 5x. So we'll divide by 5. So x is 13. Over on this one, here's the central angle, so this angle equals this arc. But we got a little problem. I didn't give you that arc, but we can find it because we know all the arcs in a circle equal 360. So if we do 360 minus 240, that gives us 120, and that's what that arc equals. So we now know that 3x plus 12 has got to equal 120. So we'll subtract 12 from both sides. So 3x equals 108, and 108 divided by 3 is 36. So x equals 36. All right, last time we also introduced inscribed angles, and you did not get any homework over this. You will today. But an inscribed angle is formed by two chords whose vertex is on the circle. So we'll draw a picture. Vertex is right here on the actual circle, and it's formed by two chords. We still have our angle, and we still have this intercepted arc, but now they're no longer equal. Now the angle is 1/2 of the arc. All right, so let's try some examples of this. So in this one, here's the vertex on the center. It's formed by two chords, so it's inscribed. So the angle, which is x, is 1/2 of the intercepted arc, which is 110. So x would be 55. Over here, example 2, vertex on the circle, formed by two chords, so it's inscribed. So the angle, that is 63, is 1/2 of the arc, which is x. So we multiply by 2, so we get 126 equals x. Now I know you're saying that these are pretty simple and you could do a lot of these in your head, but practice writing the equation because it'll be a lot more helpful later. Let's look at example 3. The vertex is on the circle. So when it's on the circle and formed by two chords, the angle, which is 2x, we're always going to say the angle equals, it's going to be 1/2 of the intercepted arc, which is 92. Okay, so we have 92 divided by 2, and we get 46. But we still haven't solved for x yet. Divide by 2, so x is 23. All right. We also did problems like this last time. Remember, we've got two inscribed angles now. Here's one. So this angle is 1/2 of its intercepted arc. And here's another inscribed angle, and it's going to be 1/2 of its intercepted arc. So if they're 1/2 of the same arc, then we know that these two angles must be congruent because they've got to be 1/2 of the same number. So 4x plus 2 has got to equal 2x plus 12. So we'll subtract 2x. So 2x plus 2 equals 12. Subtract 2. So 2x equals 10. So that leaves us with x equals 5. Okay, but what if the vertex is somewhere else? So we need some more formulas. So let's get your formula sheet back out. So we have And we keep asking ourselves, where is the vertex? That's going to be a really important question. And depending on the answer to that question depends on what we're going to write. So if it's on the center, it's a central angle and the angle equals the arc. If it's on the circle, it can be an inscribed angle, or it could look like this. And then, because the vertex is on the center, this angle right here is half of this intercepted arc. Oops, can't spell arc. Let's try that again. RC. Okay. Now this angle over here is not formed by two chords. This one right over here on the left is a chord, but the one on the right is a tangent because it just intersects the circle in one spot. So when we've got this chord and tangent, but the vertex is still on the circle, then it's half of the intercepted arc. But what if it's somewhere else? What if it's inside the circle? Now when I say inside, it can be anywhere inside except for the center. Oops. And in that the case, this is formed by two chords again. This time they intersect. So two chords. And this time the angle, and we'll say this is the angle, is going to equal 1/2. But this time when the angle stretches out, it grabs two arcs, doesn't it? So we can't just say 1/2 of the arc because that doesn't work. So we say 1/2 of the sum of the two arcs. So we're going to have to average the two arcs together. Add them together and divide by 2 when it's inside the circle. Alright, when it's outside the circle, we've got lots of different options. Okay? Well, it could be that you've got two secants that intersect outside of the circle. You could have a secant and a tangent.